All right, so we're going to begin. This should be video 4, writing and naming molecular compounds. Okay, so you just finished transition metals, and now we're moving on to molecular compounds. At the end of this, you should be able to write and name molecular compounds. Okay, so you should have your note packet in front of you. And starting from the top, it says molecular compounds is equal to on your paper. So look at the top of this slide. Molecular compounds is equal to a nonmetal plus a nonmetal. Okay, so take a minute and write that. Remember, I'm going to go to my periodic table. Here it is. Nonmetals will be in this section right here. Okay, so what does it mean, nonmetal plus nonmetal? That means you're going to have 2 elements from this same section, or you can have more, but 2 minimum, and they'll all come from this one section. So if you have 2 negatives, basically, because you know this is our negative side here, this is a -1 charge, -2, -3. If you have 2 from this section, then you're going to have a molecular compound. And what that means is that we're going to have to name it differently than all the other ones that we've done so far. So usually what we do from before, we pick one from over here and then one from over here, and then we just name it. This time we can't do that because they're both on this side. So they need specific names. So let's go back to the beginning. Okay. To name a molecular compound, you need to use prefixes to indicate the number of atoms of each element present. You, keyword here, oh, just kidding, need a pencil. There it is. You do not use prefixes to name all of them. Okay? Just because I give you all of these prefixes, not all of them need them. Okay? So look at the rules, and we're going to talk about what you should be looking for. So you're going to use the appropriate prefix to indicate the number of atoms in each element present. Okay? Change the ending of the last element to IDE. Now we talked about that. You always change it to IDE when it's a nonmetal. We know that. But the big change is right here. This exception. Mono, so you should write that in, is not used in the front of the first element's name. So if you only have one element, if there's only one atom in the compound, you do not have to name the first one. What? Let's just go on to the prefixes. So prefixes number 1. The first one you should write is mono. Okay. Second one is di. Third one is tri, tetra, penta, hexa, hepta, octa, nona, deca. Okay? And here are the 10 names that you need to memorize. You will not be given this on a test. You have to know these things. Okay? So take a minute and write all of them. And then pause the video. And then once you have them all written, let's look at our first example. Okay? We have Cl2O7. So first question, how many Cl's do you have? If you said 2, then that's correct because there's a 2 right there. The name for 2, as we can see over here, is di. So we're going to name it di. Let's see, do I have it? Oh, I don't even have it over here. I guess I have to type it. Okay. I'll just type it here. Okay. Di. So that's our first part. And then Cl, look on the periodic table. Cl is number 17, and then it'll just be chlorine. So dichlorine. Now let's look at our second one. Oops. I have an O, which is oxygen, and there's a 7. So again, let's look for the name for 7, which is hepta in this case. Hepta. And then my element is oxygen. Now remember oxygen, we have to change it, the ending over here to ide, I-D-E, so it's going to be ox. So to name this compound right here, Cl2O7, we're going to put dichlorine heptaoxide. And if we look at our periodic table, chlorine is right here, and oxygen is right here, meaning we have two nonmetals. That's why we use those names, di and tri and all that. Okay? So that's why we use di and hepta in this case, because they're both nonmetals. Okay. Let's do the first two examples, and then you can try the rest of them on your own. Looking at this one, I have nitrogen, and there's two of them. So if you put dinitrogen, that is correct. Dinitrogen. And this next one, I have oxygen, and I have 5 of them. So the word is pent, and then oxygen, which is oxide, so pentoxide. Is that right? I'm going to say it's right. Dinitrogen pentoxide. I'm pretty sure there's supposed to be an A in there. A. Pretend you put an A in there. This next one. Now let's go back. SO3. So for one, it's going to be mono. Okay, it is mono. Exception, look at the exception over here in this corner. Mono is not used in front of the first element's name. So since the first one is mono, we don't put the word mono. Okay, because there's only one, but it's the first element, so you don't put it in there. So this is just going to be sulfur, just sulfur. And then we have oxygen, and we have 3 of them, so it's going to be tri. Oxygen is oxide, trioxide. Okay. Pause the video and try to do the next 4 on your own. Okay, you should have paused the video. I'm going to just show the answers for each of them and then talk about each one. So if you got all these, you can fast forward and move on to the next part. If not, pay attention when I'm going through each of these. The first one, I have 1 carbon, but I'm not going to put mono because it's the first element, so it's just carbon. So carbon. Next one, I have oxygen, but there is only one. So that one I put mono in the front. So monoxide. M-O-N-O-X-I-A-D. Remember, we're still changing the endings of all of our words. Next one here, I have 4. 4 is tetra. P, which is phosphorus, so tetraphosphorus. Then 10, deca. And then O, which is oxide, decaoxide. Okay. Next one, I have 2, which is di. AS, arsenic. This one is trioxide. And then we have over here chlorine, because it's Cl, but we have 3 of them, so trichlorine. And then we have tetra, because there's 4 oxygens, oxide, tetraoxide. And again, you're just putting those prefixes in the front of each of them based off of how many you have. Now remember, we're about to do the next part, which is still the same kind of thing. But once we get to the mix it up, we have to really pay attention. So let's continue. This one says how many atoms are in 1 molecule of Pinson nitrogen Nona bromide. Okay. So this one you just have to break it up. Here you have penta and you have nitrogen. So let's write my formula. Nitrogen, if you look on the periodic table, is number 7. And that is N. Nitrogen. Now penta, if you remember, what number is penta? If you look here, it is 5. So since it is 5, I will put a 5 down here. Do the same thing with this one. Bromide. Now if you look at number 35 on the periodic table, that is bromine. Remember, when I'm naming compounds, I change the ending. That's why this one says "ide," but it's the same thing. So bromine is Br. And here I have Nona. If you go back, Nona is 9, which is perfect. So let's put a 9 there. So if you put them together, my formula is going to be N5 Br9. Okay, but that's not the question. The question is how many atoms are in one molecule. So this is one molecule, so we have to count the atoms. We have 5 nitrogens plus 9 bromines, so that's going to give us a total of 14 atoms. Okay, and that's it. Easy peasy. Next, we're going to be writing formulas now. Let's do the first 2, and then you can try the last 3 on your own. Look at this one. I have nitrogen. There's just one of them, so just N. And then here I have trioxide. Oxide is oxygen. And tri, if you don't remember, that means 3. So NO3. Here I have dicarbon, so that's C2. Then I have trichloride. Chloride is chlorine, so that's Cl. And I have tri, so that's 3 of them. Okay, pause the video and try the next 3. Okay, you should have paused it. If you didn't, I'm gonna let you. Here we go. Tetraphosphorus. Tetra phosphorus. So phosphorus is P, number 15 on the periodic table. Tetra means quattro, 4. And then here I have decoxide. Deca is oxygen, but deca means 10. So I have 10 of those oxygens. P4, O10. Next, nitrogen. N, tri, 3, oxide, O, di, 2. Last one, phosphorus, P, di, 2, heptoxide, so that is oxygen, because it's oxide. Hept means 7. Okay. Hopefully with more practice you're getting used to it and you're starting to memorize it. Remember, you won't be given any of this on the test. You have to memorize everything. Okay, and here we go. Now we're going to mix it up. Now this is everything we've learned so far, all mixed into one. So this is transition metals. This is regular ionic compounds. This is polyatomic ions in here. This is some molecular compounds that we just learned. So pause the video and try to do as many as you can without playing the video. I don't think that you actually paused it, so actually pause the video and make sure that you actually try these on your own. Okay, did you actually pause the video? I'm just kidding. Okay, so should have paused the video. Fe, number 26 on the periodic table, is iron. Now take a minute and look for iron on the periodic table. Find it. Okay, number 26. If you're looking at it, it's in the center, in our d orbital that we were talking about before. Remember, this is a transition metal. This can be a bunch of different charges, meaning I cannot put the charge down. I mean, I have to put the Roman numeral down because it can be different charges. So what is the charge? We don't know, because it can be anything. So let's look at chlorine. Chlorine for sure I know is a -1 charge, each one. Okay? Each chlorine is a -1 charge because it's number 17 on the periodic table. How many chlorines do you have? You have 3 chlorines. So in total, so if each Cl is -1 and you have 3 of them, then you have a 3 total. So let me say that again. Each chlorine is -1. You have 3 of them. So in total, you should have a -3 charge. Fe has to cancel out that -3 charge. So Fe has to be a +3 charge. Okay? Since Fe is a +3 charge, then I have to write 3 right here. 1, 2, 3. You have to use Roman numerals for transition metals if you do not know the charge. Fe, I don't know the charge, so I have to put Roman numerals. And then we're going to finish it off. Cl, you don't need to put tri or none of that because it's a transition metal. So this is just chloride. I'm going to type the next ones because this is ridiculous. Okay, here I have nitrogen 2, oxygen 5. Let's find those on the periodic table real quick. There we go. Okay, nitrogen is right here, oxygen is right here. They're both in this section. Since they are both in that section, then that is a nonmetal and a nonmetal, meaning you have to use the names in the front. Okay, so we talked about the names a little bit. Let me change the color real quick. There we go. So it's going to be di-nitrogen, and then I have oxygen, and I have 5 of them, so it's going to be let's say penta, and then oxygen. Remember, I have to change to ID at the end, pentaoxide. And there we go. Number 3. Let's find those on the periodic table. Let's go back to the periodic table. Oh, I've already forgot. Calcium and chlorine. Calcium is right here. Chlorine is right here. I do not have 2 nonmetals. I don't have both of them in this section over here. They're not both over there. So you cannot use di, tri, tetra, all that. You cannot use it. Only when they're in the same section. So the names for this one is going to, you just name it. I know the charge of calcium because remember we talked about it. The charge of calcium is -2 and it'll always be -2. So I don't need to put Roman numerals. So my name here will be calcium. There it is. And then change the ending again. Chloride. Got to change that ending. Chloride. Let's look at my next one. I have NaOH. Na is my metal, so let's name my metal. Let's find it on the periodic table. Where is it? There it is. Na is right here. It's a metal. It's positive. +1. Well, it'll always be +1. Don't need to put Roman numerals. Where can I find OH, though? If you remember, that's a polyatomic ion. Look on the back of the periodic table. OH, 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 OH. There it is. OH. And so let's name my metal first. So it's going to be sodium. And then name OH. Hydroxide. And there we go. Sodium hydroxide. Next one. Let's look at this one. Here I have S and F. S is right here. F is right here. Oh no, they're in the same section. We have to put the names in the front now. Okay, all those prefixes that you just learned, you got to put them because they're in the same section. So let's go back. Don't put mono for the first one, so it's just sulfur. Don't know why I wrote that one. Let's type the next part. Sulfur, and then I have 6 of them, so that's hexa, and then fluoride. Sulfur hexafluoride. Next one. Now I know I have 3 elements here, but I only have 2 things. What does that mean? I have a potassium and I have a polyatomic ion. You need to be able to tell what's a polyatomic ion and what's just an element. okay? K on the periodic table is number 19, and that is potassium. Potassium. MnO4, that is a polyatomic ion. Look on the back of the periodic table, MnO4, and that is permanganate. Potassium permanganate. Next one, CdF2. Let's find both of these. Here we go. Here is CD, here's F. Now they are not in the same section, so we're not going to use tri, di, all that other stuff. But it is a transition metal. Now remember, you have to use Roman numerals, but I know the charge of CD. It's always +2. Remember, zinc and cadmium are always +2. Everything else in the transition metals can be something different, but these two are always +2. So I don't need to put Roman numerals. So since this is, since I know it's +2, I'm just going to name it. So let's put it together. CD would be cadmium. F would be fluoride. Still changing the ending of fluorine to fluoride. Next part. AsF3. Let's see. AS is here. F is here. Now this one. Now this is where we're getting into a little murky water. Okay. Arsenic, we're going to say, is part of that section that's over here as a nonmetal. Since it is a nonmetal, we need to name it like a nonmetal. Okay? So AS with F. This is where we're going to use di, tri, and all that other stuff. Now we only have one AS, so we don't need mono because it's the first one. So arsenic. And then I have 3 fluorine, so that's tri. So make sure you put tri. And then it's going to be fluoride. Wait, wait, how do you spell it? It's embarrassing. IDE, nailed it. Okay. Last 2. I have AU2O3. Let's find both of these on the periodic table. Where is it? AU and oxygen, not in the same section. AU is a transition metal, so you have to use Roman numerals because we don't know what the charge is. So let's figure out what the charge is. Each oxygen is a -2 charge. And how many oxygens do you have? You have 3 of them, so in total that's a -6 charge. To cancel that out, AU2 has to be +6. Okay, AU2 is +6. But I have 2 AUs, as you can see. So let's just look at this part right here. I have 2 AUs, and in total they're both +6. So that means each one has to be +3. If you don't get this, call me over and I'll come explain it a little bit more to you. So this will be gold, 3 oxide. Okay. Last problem. I have NH4Cl. You need to be able to identify polyatomic ions. NH4Cl. Look on the back of the periodic table to NH4. It's the second one. Since it's the second one, what is it called? It is called ammonium. And then Cl, which is chloride. And there you go. That's all of them. Now do the worksheet for, I think it's called molecular practice.